Thank you, Hubeb, for the introduction. So, I think we can get started. Let me share my screen. Let me know when my screen is visible.
Yes, Heather, it is visible. You may start.
So, hello everyone. Hope you all are doing well. So, before we get started and dive into the topic, I would like to know maybe if you guys can mention where you guys are joining from, so that I know have idea that how many people we have and the audience uh, that I am talking to. So today I'll be covering a topic that is called LangGraph for multi-agent workflows. Before I go to the main topic, I'll be talking about some next frontier in AI development. So if you guys know about the N2NG, he is a very famous name in the machine learning and AI. He tweeted earlier this year that this year will drive a massive AI progress in the agentic workflows. So, and like by the time, like it has been more than 6 to 7 months since he tweeted, and today, like we can see there are so many frameworks that are working on this topic. So what are actually agentic workflows? So right now what we do that when the LLM came in, like early by the end of 2022, we were doing the mostly a sequential RAG or a simple RAG that was more of zero shot mode, like prompting a model to generate a final output, and then it's token by token, it is just giving the output. There's no work of revisioning, critique, or like it can analyze it output. And it is like a straightforward pipeline that runs and you get the answer. So if we talk about an agent, so what is an agent? So there are so many definitions for it, but a simple one would be an automated reasoning and decision engine. So let's say you have multiple tools, you are giving this query and you want to know how, if it has answered from multiple sources, because right now a simple RAG cannot do that. You know, you have the query, it goes into the database, it brings the relevant chunks, and you get the final answer. But let's say if your system has the ability to direct it to the source that has an answer to your query. So that is what it is. It does the automated reasoning and it decides where your query has to go or which action has to be taken. And it is being done on the runtime. Also, furthermore, we'll first be covering the theory, and after that, I have some notebook that I'll be sharing with you. And when I'm done with that, I'll be taking your questions as well. So, why agents? If you ask me, that right now there are so many data sources that we want to use in our day-to-day applications, and if let's say if I show you an example that there's a help desk solution where an agent can decide whether it needs to give a direct response or it needs to do some database lookup. So if I give you, if you create a simple retrieval augmented generation app, you give it a query, you know it has one specific database that it will look upon and will give you the response. But let's say if the response is not mentioned in that database, and you want that system to know to extract the answer from other databases. So you cannot do that. Even if you prompt it, it will not do that because it does not have the capability to decide like where to shift or how to direct that query. In that case, agents actually help you because they can decide uh, on the runtime that if it needs to select a specific tool to answer, and if that tool does not have the answer, it could redirect to the other one, and uh, if the answer is not from the tools, it can give you a direct answer which you might have prompted in the system prompt. So now talk about the LangGraph framework. So this will be our main topic actually. I just wanted to give you overview about agents. because LangGraph is one of the most trending framework. There are others as well, like QAI, AutoGen, that you might have heard about. And this is the framework that you can use to create these agentic applications where you have multi-agents. And I don't know if you guys have seen or not, recently Claude gave this model that could actually take over your computer, and it could do so many things. And it was all over LinkedIn, all over social media, that there's a model by Claude AI that it could literally take over your computer, and you just prompt it that I want this. Let's say you want to search from YouTube, and then you want to replicate that in your VS Code. So it will do line by line. You just need to prompt it. There are obviously security reasons and security problems there, but what it was doing is that it was nothing, but they were using tools. Even if you read the documentation, they were using tools. This was agentic application. They have multiple agents that can take over. One can do the specific task. So to create agentic application, LangGraph is one of the most trending, and one of the I would say, because I personally have used it, it is one of the best framework out there. So, and the reason for that is that while you want to create a agentic workflows, as I mentioned, there needs to be decisions, there would be conditional statements, there would be loops, and also if there are multiple tools, that then you need to maintain the history of your system, because how can the second tool know what was the first tool was doing? So maintaining that state is actually the most important part, and LangGraph has given all the libraries to cater that scenarios. There's one more scenario architecture that is called human in the loop. So in this scenario, while you create a framework, there is an option to interrupt the graph, and you can edit the next action based by your supervision. So these are some of the main features we'll be exploring further down the road. That what are some components that LangGraph gives us. Okay, so first we discuss about the components of graph. So graph is nothing but a relation between different entities, and you can see entities are nodes, edges, and conditional edges. We are specifically talking about the LangGraph. So nodes are agents or functions, or if I tell you in a simple words, it could be any Python function, any framework function, or anything that is doing the main task, where you have your main logic placed. That is your node. It could be any function that searches the web. It could be any function that does the retriever tool, retrieve the documents. So these are nodes, and nodes are represented by this circle symbol. And so any Python function, any framework function, anything that does the main logic, it is called node. And edges are how you connect those nodes. So let's say you have some functions, and you want that I want to execute these functions in this scenario, in this uh, manner. So you will define edges that, okay, first this node has to be done, then it needs to go to the other node. So these are called edges. Edges define actually the flow of your agent. And there are some conditional edges. So there could, as we mentioned, agents decide. So when there would be an option that it needs to enable decision making within the graph, so you'll have to decide either it needs to go to a specific node or the other node. So there we add the conditional edges. It will be very clear to you when we go to the practical exercises. But for now, you can just know the simple definitions of these components. So nodes are just simple functions or the main logic that is done. Edges connects the nodes, and conditional edges are where you decide the decision making within the graph. Now, if I show you a basic workflow, so you can see that here is there's our agent node. Maybe your query goes into the agent, and there's a conditional edge. Now it needs to decide either node needs to go to this function node, or you can maybe the other arrow you can end it. So this conditional edge would decide either it needs to choose a specific tool or it needs to end it. So here you can see the use of conditional edge. Maybe we can add another edge here before the conditional edge. We can add a simple node as well. That would be a simple edge. But conditional edge will be deciding that if there are decision making scenarios. Okay, now we talk about the state. So as I mentioned earlier, that the main component was that how the agents maintain a state. So LangGraph has given this feature that you can define a state that will be maintained throughout. If you wanted, you can customize the states. So the state is nothing but how your application processes and tracks the data. You can consider it as an memory, systems memory, which allows the other agent to remember the responses or the output from the previous agent. So state is more like a memory in simple words, because these state moves through different stages of workflow or our graph. So these are few concepts that you need to keep in mind: state, nodes, edges, and conditional edges. Now, if I show you, you can see the simple state. So we have defined this one simple state named messages. So let's say if you are creating a chat bot, you can maybe say messages. And what it does is that it actually adds the messages. It will be updating your state. So let's say from the initial response, it has some content. Then it goes to the second agent. It will maintain the previous state. But if since we have here added operation.add, what it does is that it actually appends. But if you want to override a previous state, you can also do that. So LangGraph gives us this flexibility to append the previous states if you want to use it, because obviously depends on the applications. If you have like a lot of agents, so you might not want a complete state to go to the final agent. So this is a simple state, and there could be complex state. You can define multiple, maybe your initial input, your final output, if you want to customize your states. So so far, this is what we have learned. A state typically holds information, context, or data that is relevant to the workflow. We define nodes are simple main components, main functions that executes the main logic or does the action part. Edges connects different nodes in a graph, and conditional edge is a connection between two nodes where you need to decide, where it has to decide either the other option or the different option. So it is more like a decision making node where it decides either to select a tool or either to go to the other tool. And we'll see this all in our notebook, that how it is done. Okay, so now we'll be talking about multi-agent architectures. So we actually have a lot of architectures that LangGraph actually gives us. So if you see that here we have a single agent architecture. So single agent architecture is nothing but an agent with tools. So you can see a simple agent. We have an LLM that we have bind our tools to, and it decides whether to go to a specific node or not. So it is just a basic flow or a basic simple node that decides which tool to execute, and we have binded those tools to LLM. But there is another scenario where you have multiple agents. So in the single agent, one agent, the LLM was deciding which tool to hit. But in network agent, what you can do is that every agent has their own tools. So now it will be communication between agent to agent. So agent will be communicating between each other. This is a good architecture, but there are problems. The communication sometimes not very accurate in these architectures actually. Then comes the third one. So the third one is that we have this supervisor agent, and this agent decides the routing part. It decides which tool to call. So other agent does not have to worry about uh, like calling the other agents. They just do their main logic. The main supervisor agent this main agent decides. So it has that work now, the whole work. In the network one, you see that every agent has to decide to communicate with other agent. While in this one, supervisor has that power. It will be deciding either to go to a specific agent or the other agent. Or the other one is supervisor S2. So it is the same one. Like you can say the first one, the single agent that we discussed, it is more like a supervisor. These agents could be different tools. Maybe let's say some different logic that you have deployed somewhere. You can call it a tool. So the supervisor decides which tool to call. It hits that tool, brings the response. It decides either this is the final response or it needs to move to the other agent. Then we have an other architecture that is called hierarchical architecture. If you see the supervisor and this one, they are similar. The only thing is it is branching out. So you can see this is the first one is, if I show you. So this is the main, let me, here you can see this is the main, uh, this is the main agent or supervisor agent. And maybe it can give the response to another supervisor agent which has branching, which is branched out to different multiple tools. So you can consider these as different tools, these three. And this is the main supervisor logic that decides which agent to call. And then that agent could decide the other tools. So this is the scenario. This scenario comes when you have a quite a large application and you have many tools. And the last one is custom. So this is the most important or most prominent ones. I personally have been using this as while at our company, we are creating an application where we are customizing our logic. So here you can create different agents and you can customize their logic yourself. Either you wanted to, you can maybe take different parts from different architectures, and you have the actually the flexibility to modify the workflows easily. So here you can see either you can do the agent to agent communication. You can maybe do the maybe use some supervisor agent that decides. So this is the custom architecture where you will have to like made changes or you'll have to write your own logic using different parts from the LangGraph components. So these are some of the most prominent multi-agent frameworks that LangGraph provides us. The first one is single agent, second is network, where we have agent to agent. Supervisor is the only agent that is deciding what tool we need to route our query to or our input to. And in the hierarchical, you can see that we have multiple supervisors, and then we can more branch it out. And in the custom one, it is more depend upon you that if you want to use some of the parts of different architectures, you can find the code, the complete code on the LangGraph documentation. This is just a theoretical explanation of these architectures. So I think this was the core concept about the LangGraph and how these components of the graph works. And now we'll be moving towards our practical exercise where we'll be using this supervisor S2 framework using the reasoning in Act Engine React tool, where we'll have multiple tools and we'll be creating that whole system. So I already have the code so that we have can save up some time. So I'm sharing my VS Code. Can is my screen visible? The VS Code. Can one confirm? Hello, Hubert. Can you
Yes,
Hi,
Sagar.
Agar,
tell
yes,
me?
this
If,
is.
okay, thank you. Thanks. Okay, now you can see the VS Code. Here we are going to create a simple React flow. So now first we are just importing a few libraries where we have like OpenAI because I'll be using a OpenAI model and OpenAI embedding model, and Tavily search as a second tool. So we are just importing few libraries here, and I have these two environment variables here: the OpenAI API key and Tavily API key, which I have defined in my environment variable, which I'm directly loading here. Okay, so now in this snippet, I have just created my LLM model. So we are using a OpenAI chat OpenAI model, and we are using the GPT-4 because we'll be using these LLM to decide the tool executions. So that's why we are using LLM. Now let's decide a tool. Okay. So first tool that I'm using is retriever tool. So as I mentioned, we can have multiple tools. So this is the core logic. If I show you, so this is my retriever tool, and what I'm doing is here I'm just importing few URLs. These are some blog URLs, and then what I'm doing is that using the LangChain web-based loader, I'm uploading these URLs and converting into a list so that I have one single list of multiple URLs. Now, after that, I'm splitting my data into chunks. Once that data is splitted into chunks, I'm storing that the vector store, which is sklearn vector store, and I'm using the OpenAI embeddings. So if I tell you here, we have created a single tool which is called, so as I was mentioning, it would be one of our node. So this is the main logic. Here you can see, obviously, if you create your application, you will be using some, you will have an option to upload the files. Here I'm just directly using, just for a demo, I'm using different links to show you. Now, if I show you, so this is one of my tool. Now, this is the most important part here. Okay. So you can see I have defined retrieve documents. This is our first node, and which we will be using our tool actually. So here you can see here I defined my main logic of retriever. We are just invoking here, and this part, this doc string, actually is very important. You need to tell about the arguments that your function uses, what that function is about. This is very important, and we'll know why is it important now. So this is our first tool, which is retriever tool. And what we have done, nothing, just we have made our simple main logic. And it could be any tool. You can do like, it is not specific to, you can have your any tool like writer tool, or any resume writer, or analyzer, or any visualizing tool. Any tool which has some logic you want to write, and you can just convert that to into a simple function. So this is our retriever tool. This is our first tool that we have registered. Now I am creating a second tool, which is a search tool. So I have imported the Tavily object from the LangChain, and I'm using, as I showed you, I'm using the Tavily API key, and there are free trial sums, so you can use that as well if you want to replicate it. So there are, for 1,000 requests for a month are free, so you can use that as well. So here, or there are open source tools as well, which one of them is the Go, which you can use from LangChain. So now I just created my second tool, web search. What it does is that it takes the query, and in the response we are taking the content, URLs. Simple. This is a second tool logic. So I think we are clear so far that we have two tools. First one was the retriever tool, and what we did is that we just wrote our complete logic and just converted the main logic into a single function. Or you can, maybe if you want, you can maybe put it inside a function as well. If you, so just for a good code practices, I just kept it separate. So here you can see this retriever object, I'm calling this here, and it is invoking the query, and this whole thing goes that our query takes, this tool takes our query, it converts our query into uh, embedding, and then it goes to the vector search. It looks for the relevant documents and it fetches those documents. This was the retriever tool. The second tool was search tool. Search tool is nothing, just a simple web search. It takes your query, it goes to the web search, brings out the documents. You can decide how many documents you want. There are other params as well, like max results. So you can do that easily. So this is our second tools, which is web search. So we have so far created two tools that we'll be using in our agent. First one was document retriever tool. Second was web search tool. This is the list that I have created for our tools. First one was retriever tool, this one, and the second web tool. So these are the tools variable where we have defined these tools. Okay. Now we are going to create an assistant actually. So first we need to define as we discussed about the state. So you can see here I'm defining a simple state class where I'm taking simple messages and I'm actually using add messages. So what it does, as I mentioned previously, that I want to append the previous responses or to the next response, to the next node. So if you want, what it would do, it will not override, it will append. So if you do not want to append, you can just remove it. And there are other params as well that you can use. So here we are defining a general state, which is called state class. And here you can maybe define further variables as well. Let's say you want maybe some input state as well that you want to maintain. So it will take that and it will give to the or some different plan. If you are using multiple agents, let's say planner agent, then researcher agent. So obviously in that case, you need to have a lot of state. Like you will have to the task of planner output. It would be one state. You can maybe like this. We can decide, and then maybe whatever if you want to string, or you can further if there's another agent uh, another state that you want to maintain. So you can define based on define state. Here I'm using just a default state that LangGraph provides us. And here's the main logic that executes. So runnable are simple just function that does the work on the runtime.
Whether
So
sorry
here
to
our
interrupt,
initial state, yes.
sorry to interrupt. I guess your voice is distorting right now.
Okay.
So can you
Okay.
just check it?
Uh,
Yeah,
okay. So Hubert, is it clear now?
it is better. Yeah.
Okay. Thank you.
Sure.
So as I was discussing about the state, so you can see we can define our basic state and which will be flowing between the different nodes. And after that, we have an assistant class. So what assistant class does is that it actually does the initial invoke. It takes our state and it decides either it needs to go to the tool or needs to end it. So you can see here we have runnable function. What it does is that it does the uh, it does the decision making on the runtime, and what it is taking is it is taking our initial state, which will be giving as an input. So it would be our maybe initial query that will be taking. It will be invoking our runnable function, this assistant class, and after the result it will check if there is a tool call or not. If it is, then you can see in state, this is how we are adding the messages to our state. So it will be appending the messages to state. Now this is the most important prompt.
Heather, can I interrupt
This
one
is our
second?
system prompt.
Yeah, I would
Yes.
recommend, can you just turn off your video and then we can continue. Hopefully the connection will be better in this regard.
Okay, let me.
Yeah, that would be great.
Uh, is it clear?
Yeah,
Hubert?
it's much better. I hope it will
Okay.
work. Yeah.
Okay. So now we can see that we have one system prompt that actually decides that we need to give the complete context of our tools and what routing it needs to do. So you can see here I'm defining you are a helpful assistant tasked with answering user question. So as we defined the two tools above, so we can clearly say that you have access to two tools. One is retriever document and the other one is web search. So I'm telling for any question about LangGraph, use retrieve documents. And this retrieve document is nothing but this tool that we have defined. And for any other questions, such as questions about current events, use the web search tool. So it is just a very simple general prompt that I have given, and you can customize it according to your application. Now, what we are doing is that we are taking our prompt and our tools, and we are binding it to our LLM model. So this is where, so as we mentioned that we have our LLM and it has those tools. This is the part that we are doing here, that we are binding our tools to our LLM with our prompt. So our LLM or main agent will have the context about the tools that are associated with this LLM, and what is the main prompt. It will be taking that prompt, the query, deciding the tool, and execute the tool part. Okay. So now there are some basic functions like handling tool error. So let's say this is the function that LangGraph provides. So what it does is that if while the system our workflow is running, if there is an error from the tool side, so it will invoke that error. And we are also creating a tool node. So tool node is the node that will be deciding like when we are hitting our tool. So this is the function that creates a tool node. So this is already, these are the all logics are pre-built given by the LangGraph. So you can see we are already importing it. You can also write your own logic as well, but it is already given by LangGraph. So you can just clearly use this tool node. Now here we build our graph. Hubert, is my voice clear? Just wanted to confirm.
Yes, it is.
Thank you. Now, here we are creating a main graph. And now the important thing is here we have this assistant, which is our main LLM, which will be routing to different. This is our first node. We are just noding ads. We first added the assistant node, then tools node. And what we have in our assistant node. So I just show you this assistant runnable. This will be going to our assistant class where we'll be invoking it, and it will start our flow. So our first node is this assistant node, and after that our second node is tools node, which is that we just showed you that this function create a tool node and it takes our tools. Now these were these simple nodes. Now we are creating our edges. As I mentioned, edges decide how it will flow, that from where it will start. So there's this function start function. We'll start from assistant, and this is the node that we define. And after that, once assistant has initiated, it will go to conditional edge. Now conditional edge will define either it needs to select a tool or it needs to go to a it needs to end the graph, because if it selects a tool, tool gives the answer and then it brings that answer. Otherwise, if the question is not related to tool, it will clearly say, okay, I cannot provide it, or the whatever you have defined in the prompt, maybe gracefully it will show up the answer. So now how this is in the conditional edge, we have first given this assistant node and then there's a tool condition. So what is this tool condition? So we are importing from the LangGraph, but if I show you there's a tool condition, so I can maybe write you a quick logic, because previously LangGraph has, you can copy those functions, but now they have converted into packages. So So what it does is that it actually takes the this is we are taking the messages from our state, and then we take these latest message, and what it does is that from our messages we actually take the latest message, and here we are taking the last message. So now, as I mentioned, it decides either it needs to go to the tool or end. So this tool, this tool condition, I'm writing the logic for it. Although I have already used the LangGraph has given a library for that, so we can directly import that. But if I show you, because it is an important part, so that's why I chose to show you. So what it does is that it takes a state, it takes the last message, and if our latest message uh, dot tool calls. So if our latest message has returned that it needs to go to the tool, so it returns the tools. Otherwise, what it does is that and so this is the logic that this node is doing. So what happens? Our initial query goes to assistant. Assistant decide, okay, we need to use a tool. So it goes to this node. It decides that, okay, we found a tool call in the last message, we need to go to the tool call. It goes to the tool, tool brings the answer, and you can see that that tool answer goes to the assistant and we get the final response. Let's say our assistant gave an answer in which tool call was not there, so it directly ends it and we get a final response, which could be like LLM made up response, or if you have something defined in the your prompt. So I can maybe run those quickly. Here in this R, we are compiling our complete graph, where we are adding memory saver so that it has all the complete memory about different states. So it is the option that LangGraph has given. If you want it, if you do not want it, so you can also remove it. But yeah. So here we have compiled our graph. And if we show a graph, so you can see this is how our complete graph looks like. It starts initially, goes to assistant. Assistant decides either it needs to go to the tools. You can see this arrow, dotted arrow, shows the conditional statement. If the tool has an answer, it goes to the assistant, we get the final response. If assistant decides, okay, no, we are not supposed to go to the tools, it goes to the end node that we showed in the condition. Now let's test it. So here I have, uh, as I showed you, that we have two tools. One is retriever tool, the second one is web search tool. So in the query I'm talking about, I have, as I showed you, there are some links that I have indexed in our retriever tool. So these are the links about LangGraph. These are some blogs about LangGraph. So when I am invoking our graph, so I'm asking what are nodes in graph. So now, as you know, it should go to the retriever tool, because we have in our prompt tell about that while using the graph. If there's a question about graphs, you are supposed to, and also in that tool description, we have also added that you are supposed to take it from the vector database, and this is about retrieving documents. So if I try this, so this option pretty print actually shows the complete flow, how it runs. And this is where we see what we have currently learned. So let's see how it works. So we gave our message, what are nodes in LangGraph? It goes to our assistant. Assistant decide, okay, we are supposed to call tool. It decided that what tool we are supposed to call. It decided retriever document. It gave the query to the retriever documents, which is this function that we have defined here. Now, this is the tool message. This is the tool message that our tool has returned. And in this logic, this is the tool message. Here it returned the tool. And that tool message now goes to our LLM. Now this whole message goes to our LLM, and here the AI message our assistant, which finally gave us in LangGraph nodes represent individual functions or tools that an AI agent can use. So you saw that here it actually ran that complete flow. It decided on itself that it needs to go to the retriever tool. Retriever tool gave the final response. That response we sent to AI message, and then AI decided, okay, we need to end it. It is not supposed to call two tools. Let's say if there was a query also about multiple queries where we are supposed to hit two tools, so it would then give the final response to AI. Then AI would decide, okay, our complete answer is not finished. We are supposed to call another tool. Now, there's one more example that I have for you. So let's say I have here asked, what is the weather in San Francisco? So if I hit this, you can see it took my query and it decided, okay, we are supposed to go to the tool, and it took our query, current weather in San Francisco. It gave to the our web search tool. Web search tool searched about it, that logic that we have defined. It gave the response. And after the response, our response went to the AI message assistant, and that assistant returned us a final answer. So this is how our agent is working. And let's say if I gave it, okay, so you can see how it has worked out now. It didn't go to tool. As we had discussed, our agent assistant will be deciding either it is supposed to call a tool or it needs to go to end. So you can see that here it didn't, because it knew that hi is not supposed to be answered from any tool, as we have defined in our tool descriptions, our prompt, and it decided not to go there and it gave us the final answer. So this is how our React agents work using the LangGraph. And obviously, you can customize these agents according to your needs. So this is one of the notebook that I created using the LangGraph, and we are even at our company we have been using this framework heavily in our applications, where we have like created production-based applications, and we are consuming the LangGraph there heavily. Also, we have made like custom logics there, made changes in its working. So it is quite a good tool if you want to create some agentic applications and you want to control over your application while creating the agentic application, because agents were there previously as well, like year or two ago, but they we didn't have much control over that. So LangChain has also given these agents previously, but the cyclic approach was not there. So that is what LangGraph actually helped us in catering. So I think that is all from my side. If you guys have questions regarding the presentation, regarding the LangGraph, so you can maybe share in the chat and I can answer. Okay, so I see Mark, could you explain? Okay, so in the supervisor as tools and the first one, the main difference is that in the supervisor as tools, our main engine has a context about tool arguments, not a complete state. So in that case, it has like what arguments are supposed to go to the other tool in that supervisor tool agent. But on the second one, which was like a simple agentic or supervisor, in that one we are sharing a complete state between agent to agent. Also, you can do that in the other one as well, but in the one that is called tool calling, so in that case, our supervisor has context about the arguments of other tools. So first agent has given the answer. It has went to the our main engine. It decides what arguments are supposed to be good to the next tool. And while in the normal supervisor that I showed you, in that one, we are like switching. complete state, or we are transferring a complete state between agents. Okay, I was building. Yeah, I think if you have like multiple agents, Rohan, so it can, but it totally depends how many tools you have. So if you have like oh, quite a lot of tools, so maybe other architectures like agentic one or network one or hierarchical one could be useful. But if you have some specific tools, like 2 3 tools, so uh, you can use those tools in this React agent. And I think I can share the notebook link. I'll be loading that on the hub, and we can later share that link. Okay, that's all.
I guess we
Fizak, can you maybe can if you guys can tell me what are those questions?
Yeah, so Heather, we have questions like in the Q&A box. Could you please explain supervisor as tools agent and the difference with the first one, a simple one. And the same person is asking, can the agent's reason use chain of thought to do tasks? We can
Yeah,
go.
I think
You can
yes.
probably, yeah. And we have another question in the chat as well
Uh,
from
okay, so
Dada.
okay, yeah. Okay, so I guess you can clearly use the chain of thought while reasoning, but it will be a separate agent of yours where you will have defined that complete logic. So you can use that in your agents easily. And we have some like you, if you go to the LangGraph documentation, they have some quite a lot of agents that are using these chain of thoughts, and then we are using we are while creating the node, we use that functionality in that in those agents. So I think it depends how many agents you have in your application, because if you are while you use a supervisor agent, Ron, and you have like 3 to 4 tools, then obviously it will be complex for as the line graph guys. They suggest that maybe like 3 to 4 tools are enough, because once you keep increasing the tools, it will be complex for our LLM agent to decide which tool to call. So that's why it depends. Maybe if there are a lot of like for each task you are using multiple agents, then maybe you can separately define one agent that has multiple tools, the other agent that has your tools, and those will be communicating with each other.
Yeah, Heather, we have more questions in the chat
Okay.
as well. You can just check them
Okay.
out.
Yes. Okay. uh, Okay, so yeah, how human in the loop works. So human in the loop, the initial working is that if there are, let's say, you have some flows, yeah, where you want to buy tickets, or you want to, if I tell you about this researcher agent, that you wanna decide some places, and you wanna book tickets to some hotels, and you are like creating a planner. So in that example, once it has completed few tasks, let's say it has searched the web, it found out those hotels that it has given from the search tool, and then there will be a human in the loop task. So here you can, if it asks you how many, what are the important hotels that you would want, so in that case you can maybe input your response there, and it will take that, maybe let's say the web search brought some of the hotels that you want to book for your trip. Now there are some hotels that it is showing you, and while the human in the loop, it could ask you what are the like you can decide which one to go with, and after it has taken your suggestion, it will go on to the complete execution, that other task that it needs to do. So human in the loop more like that you can give your input as well while creating an agent. So this is how human in the loop actually works normally in LangGraph frameworks. So do using LangChain quite different? Yes, yes, actually yes. So if you are using a Azure, so you will be deploying your model on Azure cloud. So it will have different APIs, obviously. Uh, or if you, it depends if you are using like deployed models on AWS or Azure. But if you want to use Olama, that is free, you do not need that. You can locally deploy that. Uh, so I think, yeah, you can maybe, it totally depends if you're using the LLMs that are hosted on Azure or AWS. So we'll be using those API subscription. Otherwise, you can use maybe locally run your LLM. And okay, so I think we quite have a lot of in our company, like we have different tools that does the task, like RAG tool, there are web search tool, and some customer suggested scenarios that we have complete logic separately that we have deployed. Like these are core end-to-end system, like pure function apps that we have deployed. These are one of the nodes of our React flow. And you can like I have worked on that part, so I clearly know that like most of the heavy lifting is being done on that function app that we have converted into one node. So as I mentioned, that node can be anything. You can even use QAI, that is more like a competitor, or I would say to LangGraph. Even if you create some task agent there, you can use that as a node in the LangGraph as well. So and it is actually working. So Rich, you asked about my experience. So for the past 2 months, like we have been like actively exploring, and it has like come out to be quite helpful for us. Like it is tackling our scenarios very well. Obviously we had to do some changes in the logic. We had to add our logic, some related to prompting and while creating the flows. But yeah, it is proved to be a quite a good experience so far. Xavier, for latency, I think this supervisor one, because in agent to agent has their own tools. So agent first decide about the tools, then agent will connect to other agents. So there would be a like latency issues. But in this supervisor one, it has just one LLM that are tools binded to, and it decides. So if you see in the context of latency, so this supervisor one is quite good. So latency issues are in the other architecture that we discussed, like hierarchical and uh, other ones. I think yes, Hassan, I agree with you, because what happens is that there are some frameworks out there, and suddenly just OpenAI and Claude just literally gave that same logic in there. And I have seen most of the startups actually like closing up after uh, most of the things were given by OpenAI and Claude. So yeah, there are some challenges for the startups, like because most of these things are being handled by like Claude, and also the O1. If you talk about the O1, it is using the chain of thought prompting. It is designing. So I agree with you that it can affect, because people will be directly using them. But when you if you if I talk about myself, my experience, so when you come to create your own applications, so like these are not some basic demos. There are so many things that you will need to do, like out of the shelf you need to do that. So in that case, you do not have flexibility. Let's say in Claude, you have no idea how it is working. You do not have the control over their chain of thought prompting. So in that case, I would say that LangChain and different frameworks, QAI, you can use them, and you can, as I mentioned, that LangGraph, we have made it according to our use case. So in that case, you can use these frameworks, and I kind of think that it is here to stay. Like LangChain and other ones, they are here to stay for quite a long time because they are keeping up quite fast with the changes. So yeah. Um, So okay, who is the best Lang? So I think Ahmad Lang. There's a difference between two. I think most of people are like confused about. So Llama Index has mostly worked on uh, the rack side, but they came up with their Llama agentic flows. I personally have not used Llama agents so far. If you talk about that agentic flow, according like comparison between LangGraph and Llama Index, in that context, I have not used it, but and I think I've not seen more of like Llama Index out there, but I cannot say much over it as I have not personally used it. I have used LangGraph and QAI as well, so I would further explore maybe. I've not gotten a chance, but yeah, they have like some same kind of Llama agents they have called it, I think, and they have all these nodes and everything. So maybe you can explore that, and so yeah, if I get a chance, I'll do share it. And if you guys have further questions, so you can maybe connect with me, or if you can share your queries with LinkedIn or anywhere, thing, so I can maybe help you if you want my help later. So
I guess we're done. We are just left with one question, I believe. For Claude, like capability to use computer, which tool we will be required? Yeah.
Okay, yeah, okay, Zishan Tariq. Okay, so Zishan, for if I do not clearly remember, but I was going through their documentation, so they have like desktop tool something, and if you wanna like you wanna create that, so you might need to explore some core like VM related tools, that how you can take over this like the desktop related tools. So I do not have much idea about that, but what I saw that they had this tool, command prompt tool. Yeah, one of that was command prompt tool that was looking into their command prompt and using those stuff. So you can maybe look into their documentation about more about, but I think that is somehow on a basic level, that is more of a doable when you know how you can look into like take over the desktop screens. So that could be one of your tools that you can utilize.